So we got our practice test up in here, and we're going to go over it. Just remember, if you guys got any of these wrong, those are the ones you'll probably want to study the most, because when we take the test, you'll need to know how to do them. And the test looks almost exactly like this. So there was a lot of vocabulary in this unit, but it's doable, right? Like acute right, straight, and obtuse ankles. All right, write the letter for the correct answer in the blank at the right for each question that has one of these. So what is the classification of the ankle shown? Well, 90 degrees would be right here, ish. And that one's a little bit more than that, so this one is
obtuse.
D, which is obtuse. All right, so if I wanted the equation for this, not that you guys had to do one, it just wants the value of x, right? But the equation would look something like this. So this is straight ankle, so these two are supplementary. I would have the 8x ankle and the 140, and when I add them I should get 180 degrees, like these. So what I would need to do is figure out the measure of just that ankle, so I know how much 8x is. So I would subtract 140. In the equation I'd subtract it from both sides, but if you just took it away from 180, that's what I assume most of you guys did. And you saw that that ankle was 40 degrees, which is the same as 8x. So, to solve for x, we would divide both sides by 8, and we would find that x equals 5. Bam. What is the value of x in the figure at the right? So if we look at these two ankles, since they create a right ankle, and we know it's a right ankle because of this marking right here, we know that these two have a complementary relationship, which is 90 degrees. So, and this one we're going to do a little bit different than the equation on the last one. So since we know that overall it's going to be 90 degrees, again, we just want to figure out what this ankle is. So we'll take away the 42 degrees of the complementary relationship, and that would give us 48 degrees. So this ankle is 48 degrees, but that would equal the 2x as well. And since all we're doing is solving for x, we would divide both sides by 2, and we would see that x equals 24. So this is a supplementary relationship between ankles 1 and 2. And they told us the measure of ankle 1. So supplementary is how many degrees? 180 degrees. Well, we got two ankles. One of them already is 63 degrees. So I'm going to take away that 63 degrees, which would tell me the measure of the other ankle. And in this case, looks like it's 117 degrees. Do we need to label this one? Yes, we do. 117 degrees. You could check this by adding 117 to 63. The reason you'd want to do that is to make sure it's 180, and it is, so it checks off. I could write that in there if I wanted to. We're just looking for the answer though, so it's not necessary that you do. On a map, a scale is 1 inch equals 125 miles. What is the actual distance between the two cities if the map distance is 2 3/4 inches? Well, what we can do on these is, each inch is 125 miles, and this one is 2 3/4 inches. There's several ways you could do it. Some of you guys know that this would give you 2 3/4, which is also 2.75. Do you guys want the decimal or the fraction on this? Oh, the fraction? Okay. As a fraction, this one would be 11/4 in inches. So what you can do is you can take 11/4, and that will tell you how many groups of 125 miles you would have. So this would be 343.75. We need to remember to label these in miles. The other way to do this is to set up a proportion, and we got inches and miles, and then we got inches and miles. So this is specifically 1 inch in 125 miles. So how many miles would 2.75 inches be? And you could use fish method to solve it. You'll get the same answer either way. And that's our answer right there. So on this one, it's asking which pair of ankles are congruent. We got this one, which would be congruent with its vertical ankle, these. So we could have said ankles 8 and 6. Now I don't know if that was part of your options.
No, it wasn't.
But
It wasn't.
on the other hand, we've got ankle 7, which is vertical with ankle 5.
Yeah.
So if this was one of the options, you could have put this one as well.
I take back my bar.
On a scale drawing, the scale is 1/4 inch is 1 foot. What are the dimensions of the scale drawing of a room that is 18 feet by 16 foot? So if I took my 18 foots, every one of those is 1/4 of a foot, inch rather. So you can multiply it by 1/4 if you want. And that should give you 9/2. If you guys like the decimal, right? 4.5.
Yeah, let's do decimal.
Don't forget about the labels on these though. So far we got a 4.5 inch. And this will be by, that's on this one it's 16 feet. And every one of those is 1/4 of an inch, so I'm just going to multiply it by 1/4. And that would give me 4 even inches. So it's a 4.5 inch by 4 inch scale drawing. On this one, if you guys were just to take 18 and divide it by 4, you'd get the same answer as multiplying by 1/4. So I don't care which of those you do, because they mean the same thing. On at these, all 3 ankles have to add up to 180, right? So if I took my 25 degrees, my other 25 degrees, and my x degrees, if I add all of these, I need to get 180 degrees.
Yeah.
Now, you didn't have to do it this way, right? Some of you guys would have just taken 180 and minus 25, 25. So if I combine these, I get 50. And then to solve with these, we'd subtract 50 from both sides if we use the equation. And then we get x equals 130 degree on a these. Alright, to find the circumference of a circle, we need to take the diameter and multiply these by pi. Now if you use 3.14, that's okay. We can just use the button on the calculator as well. In any case, what they gave us right here was the diameter because they showed the whole line. So I'm going to take 26.3 and multiply these by pi. And when I do that, so rounded, we're going to round this to 6 and yards. Now if you use 3.14, you may have gotten something a little different, which is okay. But if you're like 2 or 3 off whole units, then that's not okay. That means you may have struggled rounding, which is a big deal. What is the classification of the triangle by its ankles and sides? Some of you guys still forgot that the poster is in the back, so you could have just looked at it and classified it. Some of you guys just didn't need it, which is okay. This one, with the markings, we can see that these all have the same markings, which means it's equilateral at least. So that is equilateral. All 3 of these ankles appear to be less than 90 degrees, so that would be acute. Alright, so it's an equilateral acute triangle. Done. What is the value of x in the figure? So one thing we need to know about these 2 ankles is that they are not supplementary, they are not complementary, they are vertical. Which means that they are congruent or equivalent. So when I write the equation for this, I got 154 degrees, which would also equal the 8x plus 2. Alright, to solve for x, we're going to subtract 2 from both sides. And that leaves us with just the 8x. And that would be 152 degrees for just that ankle. No, just the 8x. Yeah, that's good. So to solve these, I'm going to divide both sides by 8. And I see that x equals 19. What is the classification of the pair of ankles shown? So we got ankle 1 and ankle 2. Those are vertical. Which name does not apply to the ankle pair? Yeah, very good. So these two they actually would be congruent in this case because they would both be 90 degrees. So they are adjacent because they're next to each other. They're supplementary because when we combine them, they give us 180, and they're both right ankles because ankle 1 and ankle 2 are one. Ankle 1 is vertical with this 90 degree ankle. Ankle 2 is supplementary with it, so it's 90 degrees as well. So the answer is vertical. The ankles shown are supplementary. What is the value of x? Alright, so we got this ankle, 3x. And we got this one right here, 96 degree. And then if I add these, I get 180 degrees. And I'll need to subtract 96 degrees, which will tell us the measure of that ankle. So 3x equals 84. We don't want 3x's, we want 1x's. So we're going to divide both sides by 3, which makes that a 1. 1x equals, bam, nailed it. Find the value of x in the figure shown. Yeah. All right, good luck.
Oh, that's wonderful.
That's some really big, you know. Oh, yeah.
Okay, I'm done.
That is correct. So yeah, we're just taking away the 90 degrees, and some of you guys didn't notice that, usually because it didn't print very well, but this one did. That is a 90 degree ankle. All right. Thank you. Please explain why you do it.
Okay. Oops. No. No. Okay. It's
Stay
fine.
over there.
Just erase it with me here. The right horse number 2. I did if the first one, if this angle is 4, then across here is 2, and they're vertical, and number 4 equals 120 degrees, so this one is 120 degrees.
Can you write that at the bottom, please?
Okay.
There we go.
120.
All right, excellent work.
There's the pen.
Very nice.
That's fine.
What is the classification of the triangle by its ankles and sides? This one's multiple choice, not like the last one. We can. All right, good luck.
Thanks. Okay. Colorful? Are those just, I
Just
don't.
do it. It's okay.
Okay. So, let me get that. So, it's B. Yep, that's how I'm going to show it's B. And because it's isosceles, which has 2 equal sides, and those represent equal. Yep. And then it's acute because it just all acute angles. So
Very
yep,
nice.
that's what I got.
All right. We're gonna
Just my nice little.
emphasize that. B. All right. So 1/4 of an inch is a foot. This also means that 4 inches would be 4 feet. I'm sorry, that's not 4 inches. That'd be 1 inch. 1 inch is also 4 feet. You can change the scale if you want into this, if that's what helps you. But notice both of them are unit rates, 1/4 inch per foot or 4 feet per inch. And in this case, we got 15 foot, which means we could take the 15 and divide it by 4, which would be 3.75 feet. And this would be by 16 divided by 4, which tells the inches as well. And that would be 4 inches. It's supposed to be inches right there. So on this one, 1 inch is 50 miles. So if you got 5 inches, 5 inch, each of these represents 50 miles. So we got 5 groups of 50, 250 miles. Bam. To the nearest tenth, what is the circumference of a circular pond with a radius of 14 meters? Use 3.14 for pi. We will not. We will use pi for pi. Alright, so we want the circumference of this thing, which is the diameter times the pi. But what they gave us up in count was the radius.
So
It's 14.
14 times 4
So the
times
diameter will be 2 of those radiuses, which would be 28 meters.
I did it.
So I will replace diameter with 28. Now, yeah, some of you guys just put it into the formula, 2 times radius times pi, and that was okay. But in this case,
175.9.
87.96 will round up to 88 total. You can put the decimal if you want, and that is in meters. 12, what is the area of the cycle? Round to the nearest tenth. So area is the same as radii times a pi, radius. And we know the radius because it gave us, well, the radius, right count. So I'm going to replace both radii with 6. And I can plug this directly into the calculator. 6 times 6 times a pi. Alright, so I've rounded this up to 113.1. And the label on this one is crucial because if you get it wrong on the test, you're going to lose a point. It's not just feet. This is area, which is 2-dimensional. So it's feet squared.